Okay, let's unpack this. Today, we're diving deep into some really fascinating timing alignments that a listener shared. Connections they spotted between, well, solar activity and stuff happening right here on Earth. Our mission, like always, is to give you that shortcut to being well-informed, packed with surprising facts, hopefully enough interest to keep you hooked. We're focusing on a pretty recent window, March through July 12th, 2025. And this time frame, it's really relevant because solar cycle 25, it's surging towards its peak right now, which means, more solar flares, more geomagnetic storms. It's an active time.
It really is an incredibly active time for the sun. And what we know for sure, like right off the bat, space weather does have clear, verified impacts on technology. No question there.
Right.
During this exact period you mentioned, we absolutely saw specific instances, things like radio communications being disrupted, GPS signals facing interference. Those are the confirmed direct links, sun effects tech.
Okay, that makes sense. That's the baseline. But, well, beyond that expected stuff, our listeners' observations point to something else. A different, almost uncanny set of data points. Can you walk us through some of the most striking, well, coincidences they noted?
Absolutely. Yeah, some of these timings are quite remarkable when you lay them out. One of the really notable ones happened back on March 28th, 2025. You had a major X1.1 solar flare erupt, and that's, one of the big ones.
X-class, yeah, powerful stuff.
Exactly. And on the very same day, you see a magnitude 7.7 earthquake in Myanmar.
Wow.
And also a magnitude 6.6 out in the mid-Atlantic ridge.
The same day.
Same exact day. The precision of that timing, it is striking.
It absolutely is. And I mean, if you're just looking at that data cold, the immediate thought has got to be, this can't just be coincidence, right? Mm-hmm. But these alignments, they kept happening.
They did. Fast forward to May 25th, 2025, another X1.1 flare.
Okay.
And it coincided with a major eruption kicking off at Hawaii's Kilauea volcano.
Kilauea, okay. Another big event.
And then even more recently, just July 8th to 10th, Mount Rainier over in Washington State, it experienced a swarm of earthquakes.
A swarm?
Yeah, hundreds of small quakes, actually. It marked the most significant seismic activity right there at the volcano since way back in 2009.
Huh. It's really hard to look at that list. Flare, quake, flare, eruption, more quakes, and not wonder, is the sun playing cosmic darts with Earth. But okay, beyond these big dramatic geological events, the observations also mention something else, more subtle, maybe, but just as puzzling. This curious case of recent whale strandings. We've seen reports, quite a few actually, especially gray whales on the U.S. West Coast, California, Washington, and many of them have this undetermined cause listed.
Right, and this is where science starts exploring some, interesting possibilities. There is a scientific hypothesis, and I should stress, it's still debated that solar activity, specifically the radio frequency interference, it can cause, RF interference.
The static,
yeah.
Electromagnetic noise.
Exactly. That noise could potentially disrupt how whales sense the Earth's magnetic field. Basically, their navigation system, which relies on that magnetic sense, might get sort of jammed or confused, leading to these strandings. It's definitely an active area of research. But it's really important to be clear. It remains a hypothesis, not a confirmed cause.
Okay, so a potential link, but still under investigation. So if we step back from the specifics, what does this all mean when we talk about the really big things, like major earthquakes, magnitude 7, 8, or massive volcanic eruptions, or even extreme weather, big floods, tornadoes, hurricanes?
Yeah, that's the critical question, isn't it? And the mainstream scientific consensus here is pretty clear. It does not support a direct causal link between solar activity and these large-scale geological or extreme weather events.
No direct cause.
Right. To put it simply, the sheer energy involved, the thing about moving tectonic plates, right? The slow, immense power needed for that.
Yeah, unimaginable power.
Or driving a huge volcanic eruption. It's just orders of magnitude greater than anything. A solar flare, even a big X1.1 flare, can deliver deep into Earth's crust or mantle.
So it's like trying to nudge a continent with a hairdryer kind of thing.
That's maybe not a bad analogy, yeah. The energy scales just don't match up for a direct push. And similarly, extreme weather, that's governed by incredibly complex atmospheric dynamics here on Earth. So while those timing alignments you mentioned are, yes, compelling to look at,
yeah,
by our current scientific understanding, they aren't seen as causally linked to solar flares. Correlation? Maybe. Causation? No.
Okay. Correlation versus causation, the classic distinction. What about other things people sometimes link to solar activity, like power outages? We hear about those too.
Yes. It's really crucial to distinguish here. The sources we looked at mentioned specific outages. Cuba's nationwide blackout on March 14th, that turned out to be a substation failure. Localized problem.
Okay.
The big outage in the Czech Republic on July 7th, a broken cable, again, an Earth-based infrastructure issue, and Europe's grid stress in June and July. That was mainly driven by heat waves putting huge demand on the system.
So terrestrial causes.
Primarily, yes. These are mostly Earth-based, localized failures. They're fundamentally different from the kind of widespread systemic grid issues that can very rarely be triggered by massive geomagnetic storms. But that's a whole different beast.
Right. A different scale entirely. We should acknowledge, though, there are alternative viewpoints out there, people who do propose more direct links, like geophysicist Stephen Burns was mentioned, proposing direct Sun-Earth connections for disasters.
Yes, and it's worth noting those. What's interesting, though, is that while these theories can sound compelling, they often lack a solid basis in peer-reviewed scientific literature. They sometimes present speculation or correlation as if it's confirmed fact, which is, different from the standard scientific process.
The evidence isn't there in the mainstream view.
Exactly. It comes back to that critical point. Correlation does not imply causation, especially with something as complex, as multifactorial as natural disasters. You need a clear physical mechanism, you need the energy budget to match up, and for these direct links, that's generally not found in the accepted models.
Okay, so wrapping this up, what we've really unpacked here seems to be this fine line, doesn't it, between, well, compelling timing, intriguing correlation, and actual established causation. Especially with these huge forces, Sun and Earth.
Precisely.
Yeah.
That sums it up well. We absolutely see clear, confirmed impacts of space weather on our technology. That's solid. And these timing alignments, they are certainly interesting, definitely food for thought. But the evidence, according to mainstream science, for direct solar causation of major earthquakes, volcanic eruptions, that kind of thing, is just not supported right now. The main drivers for those big events remain Earth's own internal processes and our planet's complex atmospheric dynamics.
So a lot to think about there. What stands out to you from this deep dive? Keep exploring those subtle and sometimes maybe undeniable ways our dynamic sun interacts with our living planet.